let one more person walk in and get started. So, good afternoon, everybody. It is my distinct pleasure to welcome you to the first of many sessions on artificial intelligence. I think this workshop series will go on for a long time because I think AI will stay with us for quite some long time. For this year, we've mapped out, I think, 4 more sessions. And today we are starting with Dr. Shaun Grannis, who I'll introduce in a minute on the fundamentals of AI. Before I do that, I wanted to thank the Regenstrief Institute for supporting this event. We get to use the space, we get to use the logistics, so thank you to the Regenstrief Institute. I also wanted to thank the Indiana CTSI, which did not put up very much resistance when I floated the idea of a workshop series on AI. Lots of people actually came to us with the question, I want to use AI in research. I want to use AI in clinical care. I want to use AI in education. And so it was very natural for us to say, okay, we'll do a broad set of workshops on this topic. And Medina, who is online, hello, Medina.
Hi, everyone.
Will regularly communicate about future instances. So I would love to introduce Dr. Shaun Grannis, who is the Vice President for Data and Analytics at the Regenstrief Institute. Much else is known about Shaun, and I will not repeat that. But one thing I've been very impressed with Shaun is how he gravitated to and assimilated AI into his life, into his professional life. So Shaun and I talk a lot about AI, and every time we talk, I'm like, oh my God, Shaun has figured out a new way to leverage, to make his life more efficient or effective using in AI. So today he will set us on the same journey to the degree we haven't embarked on it. And thank you very much, Shaun, for your remarks ahead of time, and welcome.
All right, excellent. Yeah, so I gave a talk here several months ago where I essentially said, ignore AI at your own peril. And I meant that, and I followed that up by saying I think we need to be developing some learning resources for faculty and staff. And so I'm very grateful that the Titus and the CTSI have picked this up and driven it. So most of the images you'll see in here were generated by AI. I tried to, when possible, put the prompt I used in the slides themselves so that if you want to create something similar, you can. So it's impossible for one person in 45 minutes to cover everything in AI. I think you all know that. In fact, I think it's impossible for many people to do that. AI is changing at such a rapid pace that I'm going to do my best to sort of provide a framework, a grounding for AI, and probably most importantly, I want to point you to some AI resources. I will talk about some of the projects I'm involved in, but there are many other people at IU who you will hear in this series who have different projects doing different things. So my claim is not that what I described to you today is the world of AI, but what I would like to do is hopefully give you a little stronger, firmer foundation for your understanding of AI and where to go and what to do to, either accelerate your journey or get on the treadmill and start going here. So I want to do, I'm going to see how I need to do this. I need to get this by my speakers because I'm going to play a video with sound. Okay, it should play through it. Okay, all right. Tell me if it doesn't. But this is the best explanation of the core component of neural networks and AI and large language models I've ever seen. I've probably played this for some of you if you've seen this video before, or seen me before, you've seen this video. But let's give it a shot here and see if it's gonna work.
This is a perceptron. The machine shocked the world in the 1950s by learning to recognize patterns completely automatically. And today, the algorithm it implements has become the core building block of AI systems like ChatGPT. But why is this the atomic unit of the intelligent systems we have today? The perceptron works by processing patterns we input using these switches, like this T shape. Switches in the up position output a positive voltage, and switches in the down position output a negative voltage. Each switch is connected to an indicator LED, and then to one of these dials. Rotating a dial multiplies the output of the switch by the number shown on the dial. And the meter shows the result of adding the signals from all the dials together. Now, is there a way to configure our dials such that the perceptron always outputs a positive signal for T shapes, while outputting a negative value for other types of shapes, like this J shape? Note that our shapes won't be in the same position each time. Remarkably, it turns out that if a configuration of dials that solves our problem exists, there is a simple procedure we can follow that is guaranteed to find it every time. Starting with this T shape, our meter is showing a value close to 0, but we want it to be positive. In this case, our procedure tells us to turn all the knobs that are switched on to the right by a constant value called the learning rate, and to turn all the knobs that are switched off to the left by the learning rate. Our next pattern is a J shape, so we want our machine to output a negative value. However, the current dial configuration outputs a positive value. In this case, our procedure tells us to turn down all the dials that are switched on and turn up all the dials that are switched off. Moving to our next pattern, a shifted J shape. Our perceptron again outputs a positive value instead of the desired negative value. So we again turn down all the switches that are on and turn up all the switches that are off. Arriving at our fourth and final example, the current configuration of dials outputs the correct positive value that we expect for a T. In this case, our procedure tells us to leave our dials alone. Cycling back through our patterns, we see that our machine has learned to correctly classify all 4 examples. This procedure was discovered in 1957 by the psychologist Frank Rosenblatt and is known as the perceptron learning rule.
Okay, there's more. There's a link to that video. I would encourage you all to watch it. It is so informative. So you heard the concept of learning rate. Learning rate is how far you've turned the dial. Each dial is a weight that contributes to the overall score. And you saw that you want a positive score. You want something that crosses a threshold. Excellent, excellent explanation. So that is the basis for everything we're talking about here. Now, there's certainly lots of variations on the theme, and you can start with that perceptron in the upper left-hand corner and come up with all kinds of combinations of connectedness. This is just an example to sort of show you the ontology or the different types, the typology of network configurations out there. But they all start with that single perceptron. So that's it. That's the basis. That's what we're talking about. So want to talk a little bit about the evolution of AI. A lot of people ask the question, what's the difference between AI and ML and statistics and all of this stuff? Well, those terms do not have crisp, clear boundaries. If you wanted a crisp, clear answer, you're probably not going to get one. But we know that, in fact, I'm sure many of you are familiar with logistic regression. Which is now considered by some to be artificial intelligence. Logistic regression is a closed-formed, mathematically complete solution to problems. We've since developed some tools and so logistic regression would probably be over by the jalopy, but it's still in significant use today. I use it. But then we start thinking about things like, you might have heard these terms: XGBoost, support vector machines, Bayesian networks are different algorithms that try to derive some insight from the data, but they're fairly focused and fit for a particular purpose, or we design them and train them or build them for a particular purpose. Like we do with logistic regression. We build a logistic regression model for our study. That logistic regression model is for our study. We don't intend that to be the model to rule them all. As we get into neural networks and large language models are neural networks. And large language models come from this concept of foundation models. You might hear the term foundation model. Large language models are a subset of that. You can build foundation models for images, for sound. I won't be talking about images and sound today, but other people likely will be. Not only text, I'm going to be talking a lot about text. So our large language models, the language are words, so we're building these around text. But AI in general, and thinking about the utility of them, AI models generally can be used in more broadly. There's more generalizable application. The further back in time you go, the more specific and less generalizable necessarily are those. But again, that's my explanation for you of machine learning to AI. So some of you may have seen this chart before. Claude, which is a large language model, that organization put out measurements of IQ tests. So the Mensa Norway permits large language models to take their test. So you can see the evolution here. Claude 1, IQ of 64. Claude 2, IQ of 82. Claude 3, IQ of 101. And some of you may know the way IQ scores are standardized is that the average person should score 100 on the test. So they're normalized around 100. What this tells us, this was the first time we've seen an AI do better on average than human beings can. It's one measure, it catches a lot of headlines, but it is a way of seeing the evolution. When I first put this up here, I think this came out in 24, so March of 24. So this was a year, let's say it's a year and a half ago. This is where we are now. You can see, let's go to Claude Sonnet. It's up to, what is that, 127. So Claude has gone from 101 to 127 in about a year and a half. Obviously, ChatGPT is up there as well in the quote unquote genius level. This is one of the measures of progress we can imagine for this. Language model sizes. Again, I think I grabbed this back in 2024 or 2023, where the largest models had several hundred billion parameters. So a parameter, fun fact, remember that perceptron, that single node? That is effectively, that corresponds to a parameter in your model. The more nodes, the more connections you have, the more parameters your AI model has. So here we could see half a trillion, 530 billion parameters in the models. Today, ChatGPT, while most AI companies do not release their actual statistics, ChatGPT is rumored to be using about 1.3 trillion parameters in their model now. We do know there was a model that came out of China recently called Kimi, K-I-M-I, publicly available, just like DeepSeek was. Kimi has over 1 trillion parameters as well. So these models are getting gargantuan. And there's a lot of questions around that, how sustainable, how scalable, are we going to have enough electricity in the world to actually support all of this? So there's a lot of interesting questions around this. But my point here is we continue to grow, AI continues to grow and evolve at a nonlinear rate, at an exponential rate. So when anyone asks you, so what is it that AI, these models are doing? What are they doing? They predict the next word. Fundamentally, that's what these models do. They predict the next word. So very simply, if I have a corpus, this is all of the words that I'm going to put into my model. If I have these, where are we going tomorrow and where are we at today? If I train and create a large language model and then I give it, where are we? There is a 50% chance it's going to choose going, and there is a 50% chance it's going to choose at. That's the basics of how large language models work. They contain these associations between words by reading trillions and trillions of words and building these probabilities and relationships among the words. But fundamentally, this is what they do. They predict the next word. And so I told you that there was a 50% chance of going or at. So there's some stochastic, there's some statistical randomness to these models. And I want to talk a little bit about consistency. Important for you to know, there's this concept called temperature with these models. The higher you set your temperature, I always get this wrong. I think if you set your temperature to 1, the temperature ranges from 0 to 1. If you set it to 1, you will get significant variation. Every time you ask the AI something, if you interact with it, its output is going to be different. If you put it to 0, its variability is completely minimized. I won't say that it's the same every time, but it is extremely similar every time. So a lot of the work that I do, that I'll be talking about in a little bit, I set the temperature low so that there's low variability. I want predictability, consistency in my output. So I try to reduce that variability as much as possible. There are implications for that. You might miss out on a better response by constraining it. Want to talk to you a little bit about the concept of prompting. I'm sure all of you have heard of prompting, and probably some of you may have even done some reading about prompt engineering. It's a great summary. This is not my slide, but I think this is a great summary. It's busy, but it contains the key points I want to make. One, in the blue, there are single prompt techniques where you're going to give the AI a single prompt. There's something called one-shot learning, where all you do is you give it a prompt and say, write a poem for me, and that's it. And it'll write a poem. That's that's zero shot. You haven't given it any training examples. You could say, write a poem for me like this David Copperfield poem. You've given it, so that's a few shot. You've given it the prompt and some information, some guidance on what to do. And you can imagine it just going, increasing. Then you get into the second category of using external sources. So you can actually have an AI tool use a database or a reference source or other material that effectively is, you could argue, well, isn't that just a multi-shot prompt? Sure it is, but you're giving it an entire book. So there's lots and lots of examples that you're giving it. And often if we package up those examples into a database or a book or whatever, we call that a RAG. And I should remember what RAG is. Who knows what RAG is? Somebody knows what? That's right. retrieval augmented generation. So essentially, you're using that information, retrieving information from the external source. So that's the second kind of prompt. And then there's the multi-prompt techniques. What is that? Well, we're seeing more and more of this, where you might start with one prompt that produces an output. That output then might go to back into the same model or maybe to a different model. That model creates an output, and so on and so forth down the chain to produce some more complex outcomes. So right now, many of the AI companies are starting to do things like, hey, if you give me access to your email, I can review it and schedule or do some prompting or tell you what's coming up. Those are generally multi-prompt systems. As we think about these multi-prompt systems sort of becoming more complex, we get into something called agentic AI, or using agents in AI. Agent, again, there's a lot of non-specific terminology that's used right now because the field is so quickly moving. But agents effectively are one instance of a model that interacts in some way with other models. And there are actually software frameworks now for plugging multiple models in. You sort of have a tool that can configure these, but you can imagine lots of different types of model arrangements where our single agent is our typical, give me a prompt, I'll give you a response in the upper left-hand corner, but you can start imagining all sorts of combinations. Remember that initial slide where I showed you how all the dots connect and how it becomes more and more complex? We're sort of seeing the same thing with agents now, where we're not just connecting the perceptrons, we're not connecting single nodes. Now we're taking collections of those nodes in a large language model and starting to connect them to other models in network configurations. And so there's some interesting work going on there, but that's called agentic AI. One example that I'm working on right now is de-identifying clinical text. So I'm sure many of you know that any unstructured text in electronic health records likely has protected health information in it, and that needs to be removed if you want to use it for research. So we can build two models. The first model, the happy guy, he's the one who goes in and looks for all of those 19 HIPAA identifiers to remove them. And we can train him. We can give him lots of examples, hundreds, thousands of examples to de-identify, so he gets really good at it and learns from it. Then what we do is we have the other guy review the output of the first guy. So we train the second model on the errors that the first model makes. So the second guy is very good at identifying, well, here's an example where he's going to be wrong. And you can use that information you might route it back to the model, route it to another model, route it to a human to do manual de-identification. But this is an example of how you use two separate models to accomplish a more complex task. So those are agents. I did want to talk a bit about, and by a bit, I mean only very briefly. While I do use AI in my research, the reality is, you know what daily driver means? It's like it started by, what car do you use every day to drive to work and back? Daily driver is kind of the Honda Civic that isn't super exciting. You've got your you've got your Ferrari in the garage that you take out periodically, but this is the daily driver. So daily drivers moved into technology. So you've got a daily driver phone. Some people have multiple phones. One is the one they use regularly. The other one is, they take it out with them on the weekends or something. So what I mean by daily driver is here, I use AI as a daily driver, not only in research. And in fact, I spend more time on my administrative tasks using AI than I do using AI in my research. So most of my emails now are reviewed by AI for correction. I'm very good at generating very sloppy initial text. All the ideas in there. I use voice recognition, so I talk into the computer, it generates the text. It's really messy. I then pass it through AI to correct it, clean it up, and then send it back. And right now, it's just fascinating to think about the evolution process right now. Right now, I sometimes just paste entire email threads in and say, hey, draft me a response, and then I review that response. That probably makes some of you feel very uncomfortable or makes you think, is that ethical? My belief is that will become standard at some point in the near future, because I have recaptured a lot of time in my day by not sitting in front of the keyboard thinking about, what am I going to write? How do I write this? I'm a very good copy editor, and I've got great ideas, but some of us are OCD about that first draft, and I'm one of those people who are too OCD about the first draft. I love transcribing the ideas. Now, I know there are some people who are just phenomenal with writing, like Bill Tierney. We should create a Bill Tierney AI for writing email, because that would be amazing. But so you can use it where there are gaps. We all have to generate content every day. And generating content often is, takes some time. My content generation is gone through the roof. I own every word of the content generated. I need to review every word of the content that is generated, because it's my responsibility and it's my risk and my reputation on the line. So that's super important. In fact, I've mentioned this to many of you before. Newsweek has the perfect AI policy. Newsweek says nothing about AI. Newsweek says our reporter's responsible for every single word in their article. And so that is the philosophy that I use in the work that I do when I use AI. So want to move on to some real world examples. I'm going to talk about notifiable condition detector. Apologies to you who've been here and seen me talk about this multiple times. In every state in the country has laws that require labs, doctors, hospitals to report notifiable diseases to public health to help manage disease in the population, prevent spread, et cetera. Physicians, laboratories, and hospitals do a lousy job reporting. We've studied this over and over the last over 2 decades. And so over 2 decades ago, Regan Street built the first automated detector that could look at laboratory results, electronic laboratory results, and determine whether they're reportable or not. Dramatically increased the reporting rates, and so it was a good thing. But there were errors, and it's not perfect, and we know that the unstructured data that comes from healthcare systems can be quite messy. What we did is we took a few thousand electronic laboratory reports for 3 different notifiable conditions, and we trained an existing model. Creating your own model, your own new model, is incredibly expensive. There's estimates to create a small, like a 3 to 5 billion parameter model. Estimates are somewhere around $1.5–2 million to do that, just in the compute that you need. That doesn't cover access to data and all of the other stuff. So we start usually with existing models. And then what we do is we give the existing model new data. It's called fine tuning, where you give it information and you tell it what kind of a response you would want from that information. It's like supervised learning for any of you who do supervised learning. It's basically supervised learning of an existing model. So we gave it HL7 laboratory messages. HL7 is the format the laboratory messages come in. All healthcare systems use this. And we said, okay, here's a negative chlamydia result. You should say negative. Here's a positive chlamydia result. You should say positive. We did that thousands of times. And then it learned through this process to respond appropriately. So what we then have, the original model is no longer, what we've created is a different model. It's a large language model, but it's been modified, updated, augmented with this new information. So we did a study to test the accuracy of this. I don't want to go into all of the details. Let's go on the right side here. We trained 3 models that were single, one for chlamydia, one for gonorrhea, one for salmonella. We trained a 4th model that was trained on all 3 of those. I would really like to not have to run 60 different models for the 60 reportable conditions in Indiana. I'd much rather have a single model that we could use to identify them all. So we wanted to test this capability at this level. And what we found was that the AI was just as good as humans. In fact, I'm guessing because of reviewer fatigue, AI is probably better at this than humans would be. What we found was, I'll just walk through the findings. I promise there's no test on these numbers. We found, number 1, that asking specific prompts is more effective than asking non-specific. What do I mean by that? If I take, for our single condition models, we ask the question, is there any chlamydia in this report? That's one prompt. That's a specific prompt. We could also ask that same single disease model, are there any reportable diseases in here? And it turns out that if you ask the specific model, you get very good results. When you ask non-specific models, so interestingly, even when up here with chlamydia, if I can get there, if that works, yeah, good. So non-specific prompt, but the model was trained only on chlamydia. So it should know everything there is about chlamydia. If we asked it, hey, is there any notifiable disease in there? It only identified 20% of them. But if we give that same single disease model, fine-tuned a specific prompt, we got 99% sensitivity. Don't know why that is. We want to better learn what's going on there. But that we found was interesting. So, also that single non-specific was using the untrained model too. So So anyways, but what we found was if you look at the combined models perform just as well. The combined models using a specific prompt are just as good as the single models using a specific prompt. So what this tells me practically, breaking it down, I probably can run not 60 models, but much fewer than 60 models to identify all the notifiable diseases in Indiana. So these are the kinds of things that we need to better understand, pragmatically test what will work and what will not. COVID home testing, just very simply, after the pandemic, people stopped testing for COVID at laboratories, mostly tested at home, picked up a box at the pharmacy, and then when they're positive, they come into the doctor's office and say, doctor, I tested positive for chlamydia. Either the doctor or the nurse types in, patient reports, they tested positive for, I said chlamydia, COVID. They test positive for COVID from the home COVID test. And we can read the EHR notes using a large language model to identify those cases that would have otherwise been missed. And we actually can do trending. Another point here, we talk about generative AI. You hear it's called generative AI because it generates words. It's also interpretive AI. These large language models read as good as any human being does at this point. From my perspective, I'm not a natural language I'm not a centrally natural language processing researcher, but from where I stand as a user and sometimes dabbler in the space, routine operational NLP has been solved. It's a solved problem. There are interesting additional questions around there. But if you need a tool to read and interpret what a body of text is saying, the large language models do that. Think about it. You give them prompts and they generally respond pretty well, pretty accurately to the prompts. Sometimes not so well, but they are interpreting words very well. Another real world example, I do a lot of integrating large data sets together. To do that, we need to match. The United States is the last developed country in the world without a unique patient ID. So we people who do data integration need to do patient matching with identified characteristics. I've been using lots of different types of models. Right now, we have a collaboration, Titus and I are on with the University of Colorado, where we are evaluating the ability for large language models to do this data integration for us. But not only match single patients, look for families, familial relationships, and be able to define them. So find me mother-child pairs, find me sibling pairs, find me spousal pairs, find me household pairs. So we're using the large language model in that way as well to evaluate its effectiveness. I don't know if it's going to work well. I honestly don't, but Corey was willing enough to give us some money to test the idea. Let's see, where are we? Some projects that were only beginning, we're actually speaking with some vendors right now. On my first slide, I mentioned I'm the Chief Medical Information Officer for the Indiana Health Information Exchange. The Health Information Exchange in Indiana has a lot of data on patients, and when physicians or users log in, they often have to comb through lots of data to get what they want. The concept of natural language query is to be able to either type or speak a natural query. When was this patient's last hemoglobin A1C? Does this patient have a family history of cardiovascular disease? Rather than having to do click, 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 click. No history of cardiovascular disease. If I can just ask the question and have the computer do the work for me, that would be awesome. I believe that AI may actually help healthcare workers get back to being human beings and put the responsibility for the data management back on the technology where it should be. Natural language query is one example. I'm going to skip over a couple of these. You can summarize charts as well. Chart summarization is another interesting opportunity where you might say, hey, can you please summarize the patient's cancer risk profile? Can you please summarize the patient's compliance with a diabetic treatment protocol? Those are sort of like natural language queries, but they're generating more text and more inferencing. I'm a family physician. Please summarize, please create a visit note for this patient, starting with their current vitals. I can do something like that. Again, content generation, let that be with the technology. These are ideas. They have to be proven. They have to be evaluated. In the same way that we're evaluating notifiable condition detector for how it behaves and what way we have to use the models, tweak the models, there's a lot of work that needs to be done to actually figure out how to get these into operation. You can simplify reports for patients. There's a lot of work going on right now here. I wanted to just mention something called ambient listening because this is rapidly entering into the healthcare system. So instead of a physician sitting at their keyboard and looking at the patient and asking them questions, we now have the ability to come in with a recording device. And that recording device captures what's being discussed. That information is sent to an ambient listening provider who typically has an AI model trained on your vocabulary, your speaking, and then a human being at the ambient listening will review and make sure that there's nothing crazy in there. Then the physician gets this note back and reviews it and approves, edits it and approves it and moves on. I won't belabor the story. My wife gained 3 hours in her day when her practice went to ambient listening. She gained 3 hours in her day by going to ambient listening. In my career as a medical informatician, ambient listening has had the greatest impact on the life of physicians that I've seen. We went through the Hades of EHR implementation where it was done wrong and created more burden for physicians. I think we might be coming out of that era slowly because of things like ambient listening driven by these large language models on the back end. Resources at IU, where do I go, Shaun, if I want to learn more? And I'm generally work at IU, and what should I be doing there? So again, these slides will be made available. You've got the QR codes and all that. Oh, QR code is off the side of the slide. Whoops. So at AI, AI at IU at that URL. IU just announced an AI Academy for faculty, staff, and students. They have a big, long press release at the bottom. It says, the class has not been released yet. Stay tuned for more. But they have plans real soon now to deploy this, and I would encourage you all to take a look at this. I'm very interested in seeing what they have to offer here. Where I think CTSI is the differentiator is we're thinking about AI in healthcare specifically. More services. So these, if you want to use AI in your work at IU, these are the resources you can use, approved by IU, okay? You can use the, and most recently, Google Gemini has been approved. So you can log into Google using your IU account and be able to use Gemini. I think that Gemini is much better than the Copilot we've had access to for some time. It's significantly better. Copilot's been frustrating to use. You can do image generation with Adobe Firefly. That's really cool. There's some really powerful tools there for us to use. I'm amazed at that. And then for either you or your teams technical teams that you work with, there's opportunity to write code to connect to large language models. Very specifically, for our COVID home test where we read EHR data, we used a HIPAA secure environment that had ChatGPT-4 in it. We sent a note over securely to this HIPAA secure environment. We ran Microsoft's version of ChatGPT-4, and then it returned back. And we can do that now. So we can actually, if we want to look at protected health information, and if you have permission to do that, there's still many questions around how people are using AI, particularly with healthcare data. So expect to receive a lot of scrutiny if you propose to use AI with your clinical data. But we do have the ability to do that today in a safe, secure way. It takes some technical chops because you got to write some Python libraries and be able to respond to the API, but it's there. What else is interesting? I'm just going to say for the record right now, other than this very complicated Rube Goldbergian method to get into Azure at Microsoft in a HIPAA secure environment, IU has nothing for us if we want to use PHI. There's many of us have been talking to them about it. What I've had to wind up doing is buying my own server, install it in the IU infrastructure where we can guarantee the safety and security of the data there. And we only run models locally. We do not reach out to the internet to run models. We only run models locally. The work that I did with the laboratory results, we brought a model down to our computer and retrained it there. But you need special equipment to do this stuff. And right now, IU is not providing I think, sufficient amounts of that. I hope with everything that they've started doing here that we're going to see more of this, but please write your congressman if you would like to see more capabilities for healthcare researchers to work with clinical data. And oftentimes there's concern not only about identified data, but de-identified data as well. So many concerns abound. Many of my colleagues at other universities are full steam ahead. And here at IU in healthcare research with AI, we are not. Unless you invest your own money, very expensive money. These servers are not cheap unless you buy that capability. Again, I hope that we might see it in the Realms API service. They're going to be setting up a Llama instance. I don't know what other models they're going to use, but IU is going to download models into the IU infrastructure and grant us API access to those. I don't know if that's going to be HIPAA secure or not, but more to come. And the disclaimer at the bottom here is super important. The tools listed on this page are approved by IU. Any other tool is not. So anything, any data that relates to your work at IU, from emails to writing reports to whatever you do with AI, it needs to be done within the confines of the approved services. Other online resources, very quickly again. Now these QR codes you can see here. These are social media resources that I use regularly. I periodically hit AI at IU just to see what's new and exciting. A few podcasts. New England Journal of Medicine AI has a that's a online journal. NUGEM has created an AI journal that healthcare AI. I think it's very informative in these early days to see how other people are doing research. Practical AI podcast. This person goes through, and you could just hit all of the historical ones as well. This person goes through different prompting strategies. This person goes through what is fine tuning. They really do a deep dive. So the Practical AI podcast I really like. This Week in AI and ML, TWIML is what it's called. Much more technically sophisticated. They interview current researchers in AI. So recently they interviewed a gentleman from MIT who was thinking about how to inject creativity into large language models. Because right now, what these models do is basically they reflect existing knowledge, not new knowledge. This researcher is thinking about ways to inject a signal. So you've got word coming in, and then the AI sees, oh, signal, I need to be creative. Go run this routine, the creativity routine. Then come back and start processing again. So that was very interesting. They're about hour-long podcasts. Again, a little more technically advanced, but I really like that one as well. AI Daily Brief, it is what it says. It keeps up to date on the current happenings. The series, Intro to Neural Networks, is on YouTube by 3 Brown, 1 Blue. I don't know if any of you have heard of them. Excellent explainers, excellent teacher, can start you from zero and get you to hero. There's the Perceptron video that I played for you. I put a link in there, but it continues and has some nice ones. And then there's another really nice single. So the series up there are multiple videos, multiple hours. The one in the bottom right is a single 1 hour talk that again goes through basic technical principles. And I'm sure there are many others. Obviously, there are many others. These are the ones that I've come across. Online courses in AI and healthcare. The one on the left is at Stanford. The one on the right is at Harvard. And they both are not free. You can audit them for some of the courses, but there is a lot of excellent educational software out there. I follow edX and Coursera. And these were the two that popped up as interesting to me. And in full disclaimer, I paid for the Stanford course. And it's good. What else? Books and reports. So if you have nothing else to do in your life and you're sitting around eating bonbons, here are some books to read that I found are very informative. The one on the left is a little dated, but it's still, it walks through some very interesting medical use cases. The one in the middle, Eric Topol, I don't know how many of you know him. He is a prolific writer on all things healthcare and technology. Very insightful book. And then finally, the one on the right is more technically advanced. It's a Springer series book, but it goes into approaches to using AI with medical data, clinical data. National Academy of Medicine has several reports. I just chose two of their most recent. You can scan their site for more. Software, I just want to make one pitch. So if you want to learn more, play around with large language models, just to learn how they work, not with any IU data. If you have a good GPU, so any of you that have a MacBook M1 or greater can use this tool because the MacBook M series have really good GPU capability in them. Or if you have a powerful desktop server with GPUs on it. LM Studio allows you to select from the thousands of models on Hugging Face. Hugging Face is a resource where it's a repository for models. You can choose, like, if I wouldn't do this, but if I wanted to share my models with the world, I could post them to Hugging Face. Hugging Face is almost like GitHub for large language models, if you know what GitHub is. It's a repository for models. LM Studio uses this repository. You can go through and click, it automatically downloads the model for you. It has a chat mode where you can just chat with it, download the model, load it, start chatting with it, just like you do ChatGPT. It all happens locally on your machine. Or it actually has an API mode where if you're more technically inclined and want to write some code to ping the API, you can do that too. Most AI vendors are using a standard API. OpenAPI created it. Most vendors have adopted it. So if you write code against LM Studio and it works, it should work with OpenAI API, Google Gemini API, Claude, so on. So this is actually a nice dev test tool for what we do. And with that, I've come to the end, and I'm sorry I didn't leave more time for questions, but that is it. Happy to take your questions.
Thank you very much, Shaun. That was a very comprehensive and foundational introduction. So thank you for fulfilling our dream for our first session. So we have 221 attendees online, and we have about 40 people here. I'll give you the first right of questions, which I'm sure you have. If not, we will go to Medina, who's moderating the online question. I'm going to get some exercise and hold the microphone.
Oh, sure. Thank you. Shaun, great. I learned a bunch about AI, and I'm gonna say I'm one of those people who are a little bit worried about AI. It's getting better. Just put the growing pains there.
Yeah.
My question is from a traditional researcher. I mean, the folks who can write codes and who are doing data research. I mean, I think they should be well versed in AI compared to, say, us traditional researchers. If you have some advice for folks who are at that place doing traditional health services research, clinical trials, where do you think this is going and how we can incorporate it to be more competitive in the coming era?
So that's a great question, and I could spend a long time answering it, but let me just highlight a couple of pieces. Number one, as health systems like IU Health begin implementing AI solutions, those solutions need to be evaluated. The health outcomes using this new technology is super important. That's number one. Number two, it's been never more true than it is today that science is a team sport. I would encourage you all to become best friends with a computer scientist. I would seriously start figuring out who works at Luddy and figure out if there's some people who are interested in working on this, because you do need a technologist who understands how this stuff works if you're going to build your own methods and sort of do some innovative work and trying to build new functionality that you don't think exists out there. If you're going to be, there's a lot of work in the implementation science space that's coming down the pike. In fact, some of the National Academy of Medicine work has been talking about how in the world do we implement this? You know, what does that look like? What are the processes needed? So I think there's a lot to think about there. Third point, and then I'll leave it there. These AI models are the worst they'll ever be today. They're only getting better. And I don't think we can wrap our minds around what that means. I don't know what it's going to look like in 3 years. But if it continues that nonlinear growth, these things are going to be able to read as well as we do, probably. I mean, you may be aware of some studies. I should have put it in my talk. Stanford has been doing some really good studies where these tools actually are better diagnosticians than clinicians are. So I think there's going to be a lot of research and understanding, okay, the tool is awesome. How do we get it plugged in with these human beings? For a long time, maybe for the rest of our careers, there is going to be a human in the loop for most use cases, meaning that AI is going to generate something, human beings are going to review it to make sure it's right. And at some point, we're going to get the human out of the loop. I don't know that that's going to happen in my lifetime. I didn't think we'd get to this type of AI in my lifetime, so what do I know? So those are things. Become friends with a computer scientist. Think about how you can evaluate these tools as they come in. And number 3, what was number 3? I just said it.
Human in the loop or not?
Yeah. Well, anyways, it's recorded, so you can hear.
And as an addendum to Shaun's answer, we will dig into clinical research, for instance, in future workshops. With this, for instance, Rachel and her team are going to do a workshop on qualitative research in November, December or so. So we'll get to those topics. And if you have specific questions, put them in the survey that Medina is going to send out, because that'll help us conceptualize more sessions. Next question.
It's already in the chat, Titus, the survey.
So, the survey is already in the chat, so you can retrieve it by just going to the meeting chat.
Shaun, I appreciate the fact that when you said that something that improves the quality of communication, it doesn't matter how it happens, right? As long as it's good. I don't have the confidence that that's going to happen. I was chief of medicine at Eskenazi Health when you could start cutting and pasting notes. So you take yesterday's note, cut it, paste it, edit it for today, right? They didn't edit it. But they just added some stuff, and they didn't remove the stuff that's no longer active. The chart became unreadable. And I found that out because I was responsible for reviewing the chart of every patient that died on the medicine service. And the only place I could actually follow what happened to the patient was in the nurse's notes. The physician's notes were unreadable. So how do we generate confidence that the user is actually going to take, if my AI is responding to your AI in an email, then where does the human being in there? And how do we make sure that actually happens? Because it didn't happen with cutting and pasting.
Right. Well, a human in the loop strategy, I mean, AMIA is pushing very strongly for human in the loop with AI to make sure that things like this happen. There's a lot of work going on right now, Bill, to evaluate or the methods aren't fully there yet, but to evaluate how what the AI produces is what's expected. So how do you build those tools? And it's actually, as you can imagine, complicated, but that is an area of research. It's more of a computer science space, but it needs to be informed by healthcare to, in the same way that you have copy paste detectors now, you will have that. But here is maybe the most controversial thing I'll say today. I think AI is going to worsen the digital divide. My theory of intelligence is that intelligence doesn't exist, curiosity does. Those who are curious are going to explode with AI. They are going to learn more, be faster. Those who don't care, Those who don't care about a good note, those who don't care and just want to do the least possible are going to use AI in that way. You know, tools can be used appropriately and inappropriately. And I think that we need to build as many safeguards. Some of those, I don't know how we're going to build them, but human in the loop is right now the way to do it, to ensure that we don't get this AI back and forth with no human actually figuring out what's there. But we got to figure that out. I mean, that is a research question.
Okay, Manga is going to ask the last question from the online community. We have more questions, but we have also more sessions. So Mangai, go ahead.
The first question we had was when you were talking about the temperature gauge between 0 and 1, was that variability in the word choice that you were talking about?
That was variability in the output. So if you set temperature to 1 and ask it to write an essay on George Washington, those two essays are going to be very different. Or at least they'll be as different as they ever will be. If you set it to 0 and ask it to write an essay about George Washington, those essays are going to be very similar, if not identical.
Okay. And then do you know with Gemini at IU, is VO3, their video player, included? Do you know?
I don't think it is, but you can, this is the good news. Log in right now and you can check it out and you can find out if you have an IU account. And if you don't have an IU account, talk to a friend who does.
And the last one we will ask you after and include it in the follow-up email.
Okay. All right.
All right.
Thank you.
Thank you, guys. Thank you, Shaun, for a great presentation, and thanks for coming.